Hello everyone, my name is Jamal DeShazer and I'll be presenting to you the geochemistry of the Flint water crisis. Over the next few minutes we're going to explore what happened when Flint's water system failed, why lead got into the water, and what this teaches us about keeping water safe here in Michigan. What is the Flint water crisis? In 2014, Flint switched water sources to save money. Old water came from Detroit and new water came from the Flint River. The problem was the different water creating different chemistry. No corrosion control made it so that lead got into pipes. Lead dissolved into drinking water, and in 2015, it got extremely bad, affecting about 100,000 people. Even though the water chemistry changed, the pipes did not, however. What impact and importance does this have? The health effects. There are many health consequences from this. Lead exposure linked to neurological damage, especially in children. Kids exposed can have trouble concentrating and gain behavior problems. And some of these effects could be permanent. About 9,000 kids under 6 years old were exposed to this water, and thousands of adults were affected as well. The environmental justice part is that this happens to low-income neighborhoods, mostly black communities in Flint, to be specific for this situation here. They didn't choose the water source that they have, and nobody warned them properly about what was to come. This shows how pollution hurts some people more than others. Why should we care? Flint is right here in Michigan. Many other Michigan cities have old pipes like Flint did. This could happen to any of us, and our water comes from the Great Lakes system as well. This shows us what happens if we don't take water safety seriously. An example would be Benton Harbor, which has had similar problems to Flint. If we understand what went wrong in Flint, we can stop it from happening to us. The geochemistry. How did lead get into the water? Detroit water versus the Flint water. So Detroit had less acidic water, which had minerals that protected the pipes, and Flint water did not, having the complete opposite. Their water was more acidic, which had less protective minerals. The old pipes had lead solder holding them together. What happened was the lead solder, which is normally harmless and solid, began to dissolve in the water. Or began to dissolve because of the water, Lead ions go into the water and people drink the water, leading to them being poisoned. It got so bad because nobody added the chemical protection that was needed. That chemical coating keeps lead from dissolving, and Flint didn't use it to save money, so the lead kept dissolving into the water. Who worked on this problem? Government agencies such as the Michigan Department of Environmental Quality worked on this, along with the EPA, and the Flint City Council joined along somewhere down the line. Research organizations such as the Virginia Tech Research Team and University of Michigan researchers played a huge role in this as well. There are other health organizations that help, but the scientists at Virginia Tech University were very, very useful and the main heroes in this sequence. They discovered the truth when the government wasn't being honest about it. And that's why independent science is so important. Water chemistry is everything when it comes to water safety. pH is super important, and adding the right chemicals prevents problems like this. It may cost money, but it saves lives in the long run. This crisis wasn't an accident, and it was indeed preventable. The city ignored water chemistry to save money and ended up with a disaster. That's the lesson here. You just can't ignore science when it comes to water safety. A key takeaway from this would be understanding water chemistry is essential for preventing future crises. What we learned. We've learned about the importance of water treatment and geochemical monitoring, how geological and chemical factors in water systems affect public health, the relevance to aging infrastructure across the Great Lakes in the United States, and we also learned about why geochemistry matters beyond the lab, being that it is an environmental justice issue. Infrastructure is a big problem. Scientists outside governments can catch problems as well, and pollution hurts some communities the more. We can prevent this by replacing old pipes, monitoring water constantly, and using science to make decisions. Not cost, not convenience, but science. For the Great Lakes, this could happen to any cities around. This could happen to Toledo, Saginaw, or even a city closer to us. We need to invest in water infrastructure now, and Flint teaches us what not to do. Environmental geology isn't just about rocks and dirt, but it keeps us healthy, understanding water chemistry and how it can save lives. In conclusion, water chemistry isn't just a scientific curiosity, but it's a matter of public health and environmental justice. The Flint water crisis shows what happens when we ignore science, and it also shows us how to do better going forward. Thank you guys for listening to my presentation, and have a good day.